Hello, my dear students. Welcome to Fatih's Academy of Easy Learning. Today's video, we are going to discuss about the heating effect of electricity and its uses. Let's move on to the video. You can see three devices. First one is soldering iron, second one is an electric stove, and third one is an electric heater. Normally we use this as a water heater, isn't it? In all these heating appliances, there is a part which actually converts the electrical energy into heat energy. Which is that part? What is that part actually called? Which material is used to make this part? And what are the peculiarities of such substance that we are going to discuss here? Okay, what is the part which actually converts the electrical energy into a mechanical energy in such devices like this? That part is called what? Heating coil. What is this heating coil made up of? We all know what is that made up of. It is made up of an alloy called nichrome. Nichrome is an alloy of nickel, chromium and iron. What should be the peculiarities of this such substances which makes heating coils? That should have high resistivity, ability to remain in red hot condition for a long time without getting oxidized. What else? High resistance, then high melting point. That all should be the qualities of an heating element, isn't it? What are they? Let's see. Let's see, we have it in detail here. Heating coils are made of nichrome. I already told you, nichrome is an alloy of nickel, chromium and iron. Let's see what is the advantage of using nichrome in an electrical appliances, heating appliances. The peculiarity of nichromes are high resistivity, its high melting point and ability to remain in red hot condition for a long time without getting oxidized. Okay, these are the peculiarities for the nichrome. That is why we use it as a heating coil. Okay, next we are going to discuss about another device which is safety fuse. What actually we uses the safety fuses are for? What is the use of safety fuse? Safety fuse is actually a device that works on the heating effect of electric current. Okay, but what it does, it actually protects our electrical devices from overflow of current. Okay, if an excess amount of current passes through any electrical circuit, the wire get heated and it will burn and the sub appliances will be saved from the overflow of current. Let's see certain questions related with it. Which are the circumstances that cause high electric current leading to the melting of fuse wire? Actually, what is a fuse wire? Let's see what is a fuse wire is. We told the nichrome, which is used as an heating coil, is made up of nickel, chromium and iron, whereas the fuse wire is an alloy of tin and lead. That you have to remember is the main part of a safety fuse. Alloys are used to make fuse wire. Fuse wire has a relatively low melting point, whereas what we learned in the heating coil, it have high melting point, whereas for a fuse wire it have low melting point. In each circuit, the fuse wire should be used in accordance with the current flowing through it, isn't it? Which are the circumstances that cause high electric current leading to the melting of fuse wire? There is two cases when high electric current could be passed through a circuit, which are short circuit and overloading. What is that? Short circuit and overloading. What is a short circuit and what is overloading? Let's see that. If the positive and the negative terminals of a battery or the two wires from the mains come into contact without the presence of a resistance in between, they are said to be short circuit. Okay, short circuit is a one reason for having the flow of overcurrent, and the another reason for the flow of uh, current through the circuit is a circuit is said to be overloaded if the total power of all the appliances connected to it is more than what the circuit can withstand. If there flows a current more than a circuit can withstand, then what we say, there is an overload. Okay, so short circuit and overloading is the two cases when high electric current passes through a circuit. How is the fuse wire connected to a circuit? You should remember this point, how it is connected in series. Okay. You know what, according to Joule's law, more heat will be produced when electric current is increased. What happens to the fuse wire due to this? We already told that when a high current is passed, as the Joule's law implies, the expression for heat is H is equal to I square RT. If I is more, then that produces more heat, which will leads to the melting of the fuse wire, and hence the circuit is saved from the overflow of the current. Okay, when heat is generated, why does the fuse wire melt? When heat is generated, the fuse wire is having low melting point, so it gets melted. Okay, when the fuse wire melts, the circuit is broken. What happens to the current in the circuit? Then the current in the circuit also breaks. It also stops, and thus protecting the devices from the overflow of current. Why is the fuse used in a circuit called safety fuse? Why we uses it as a safety fuse? Let's explain the reason for it. Okay, what is the reason? Okay, let's see. It's clearly here. During the entire time of the passing of current through a circuit, a small amount of heat is generated in the fuse wire. Always when the current is passed through the circuit, a small amount of heat is always produced in the fuse wire. But this heat will be transmitted to the surroundings. That heat will be transmitted out to the surrounding. But when the current that flows into the circuit exceeds the permissible limit, the heat generated become excessive. What it means, when the current flows excessively, the heat generated will be excessive. Since more, and at that time more heat will be generated and the fuse wire melts. Safety fuse is a device which protects us and the appliances from the danger when an excess current flows through the circuit. Why it is called a safety fuse? When an excess amount of current flows through the circuit, the safety fuse wire melts and hence breaks the circuit. So that will protect the devices from the overflow of current. Okay. Then what we have to what we should ensure when we connecting a fuse wire in the circuit, we should check the ends of the fuse wire must be connected firmly at appropriate points. Okay, one point, the fuse wire should not project out of the carrier base. That should be we should check. The next point is we should use thin wires so that the resistance will be what? Resistance will be a low resistance, and hence it can melt easily. Okay. What electric gauge amperage, that is for additional reading. We studied about the nichrome, which uses as the heating coil, and the alloy of tin and lead, which uses as the safety fuse and its peculiarities. Next, we are going to teach discuss about the electric power. Okay, what is an electric power? Let's see. You have noticed in all of the devices like 500 watt, 250 watt, 300 watt, 30 watt, etc. Isn't it? That represents what? That represents the power of that electric power which can withstand by that appliances. Okay, the amount of energy consumed by an electrical appliance in unit time is its power. Power is calculated using P is equal to W by T. What is the unit of power? Unit of power is what? Joule per, joule per second, or which is called watt. Okay. According to Joule's law, the heat generated in an electrical circuit in an interval of time t second, or the work done is H is equal to I square RT. We already discussed it in details. Hence, work done is equal to I square RT. Time is equal to T. Therefore, power P summum P is equal to work by time, which is equal to H by T, or power P is equal to I square RT by T. T and T cancel, so P is equal to I square R. We got first expression for power as P is equal to I square R. Then we have from Ohm's law I is equal to V by R. So substituting in P is equal to I square R, the value of V by R here, what we will get? V by R the whole square into R, V square by R square into R, 1 R here, and this R get cancelled, and we will get one more equation for P as V square by R. Then we have R is equal to V by I. So substituting here, what will happen? I square P is equal to I square into V by I. One I in the numerator and the one I in the denominator gets cancelled. Then we will have P is equal to I into V, or VI. Okay, you can remember it as P is equal to VI, or VI is equal to P. Okay, so we have three equation for power. One is P is equal to I square R, another one is P is equal to V square by R, and another one is P is equal to VI. The unit of electric power is watt, which is represented by the letter W. Okay, now we have one important thing to remember is we have one more equation to remember is that amperage is equal to wattage by voltage. Amperage is equal to wattage by voltage. Amperage means the maximum amount of current that can be passed or that can be circulated over an electrical circuit. That amperage value could be calculated as wattage by voltage, W by V, that we have to remember. Okay, an appliance of power 540 watt is used in a branch circuit. If the voltage is 230 volt, what is the amperage? Amperage is equal to wattage by voltage, or power by voltage. Amperage is nothing but the current. Okay, wattage is power. So W is equal to what? 540 volt, and V is equal to 230 volt. Substituting, we will get 540 by 230 watt, 2.34 ampere, or the amperage is 2.4 ohm. Now we have another question. A heating appliance has a resistance 115 ohm. If a 2 ampere current flows through it, what is the power of the appliances? We have given two values, R is equal to 115 ohm and I is equal to 2 ampere. I and R is given, then we have to have the equation of power is P is equal to I square R. If V and R is given, then P is equal to V square by R. If V and I is given, then P is equal to V into I. So which are the values? According to the values, you can use the three equations. Okay. This is also very easy. This is the I is equal to 0.4 ampere flows through an electric bulb, and V is equal to 230 volt. What is the power of the bulb? Then power of the bulb is given by P is equal to V into I, which means we have V is equal to 230 volt and I is equal to 0.4. So 230 into 0.4, that much watt. Okay.